Good morning, guys. Hope you're all well. Welcome to another video on Python fundamentals, and we are continuing our functions and methods series. In this video, we're going to talk about a very special technique in programming that deals with functions. We're going to talk about recursion. All right, it's going to be quite a short video because we have, I guess this topic is it's quite hands-on. So we're going to move to Visual Studio soon. So let me just give you a breakdown of what recursion is. So let's not forget, what is a function? A function is essentially a piece of code that is used to perform a single related action. And you remember, we usually have an input, which can be an argument, right? The argument is what replaces the placeholder, otherwise known as the parameter. And those arguments are manipulated in the process. We carry out some instructions based on what we want, all right? And then we output that back to the user as a result. Sometimes we can just print out something to the screen, or we can return a result of an operation and store it as a variable. And we can store it as a variable. So what is recursion? Recursion is a technique where a function invokes itself, right? And usually it's used to create clean and elegant code, because you can just write something that would take you a bit more chunky code, where you would otherwise be using like a for loop or a while loop. You could just write a recursive function, and in 2 or 3 lines, then you're done. However, if there is no base case, usually referred to as the terminating condition, you could run the risk of your function entering into an infinite loop. And this is quite memory intensive and can, if you're not careful, can cause your computer to crash. Now, so just below we have a function called fun, and it takes in a parameter or an argument n, which is a value integer. And it says if n is equal to 0, return, otherwise print hello world. And then we run that function again while decrementing n. Okay, we will show you this in the Visual Studio Code examples, how it works, and I'll also draw some tracing trees, recursion tracing trees, that will help us to trace how the recursion function is operating. So just to round up some advantages and disadvantages of recursion. So it's used to create clean and elegant code, like I said. So, and secondly, complex tasks can be broken down and simplified using recursion. You don't have to write numerous lines of code just to solve a problem. You can just break it down to a recursive function, and that will be it looks quite simple. All right. Sequence generation is simpler with recursion compared to nested iterations. Remember, I said you can create clean code and simplify tasks. So that is one task that can be simplified. However, we have disadvantages. So the logic behind recursion can be hard to follow. However, we're going to draw some recursion tracing trees just to assist us with how we can follow the recursive function. And then recursive calls are expensive and take up a lot of memory and time. That is a big disadvantage. So just be careful how you use recursive functions. If you can write it in a simpler for loop, then you don't necessarily, or a loop statement, you don't necessarily need to use recursion. And then finally, recursive functions can be difficult to debug. All right, remember that. So we're going to go through some examples of recursion using the Fibonacci sequence and the factorial. So the Fibonacci sequence is just a sequence in which a number is the sum of the 2 preceding numbers. And so usually the common way that the sequence starts is either between 0 and 1, 1 and 1, and 1 and 2. And I don't know if you've heard of the golden ratio, but this is just an example of that, right? And there's just some definitions of the sequence. So for whatever index that you have, it's essentially the sum of the 2 preceding numbers, excluding the first 2, 0 and 1, right? Yeah. So n is greater than 1, right? So let's continue. And then the factorial, it's just where, as you can see, I've written down the formula for the factorial, and we'll give an example of just 6. So you just take every number up to 6, from 1 to 6 to that number, multiply, and then you'll get the factorial of that number. So finally, just some takeaways. Remember, recursion is where a function invokes itself in the function call definition, right? Recursion is used to create clean, elegant code. It can be memory intensive and can be hard to debug. All right, guys, this is just a quick short slide presentation. Let's move over to Visual Studio Code. I'll see you guys there later. Cheers. Good morning, guys. Welcome back to Recursion. All right. Now, I want to talk about something quite interesting called function of control. All right. The control flow of a function. Let's quickly define functions. It's just going to be just to demonstrate something. I'm calling a function called called func, and I'm going to create a value called create a variable called val and store the number 25 to it, and that this function just returns val, right? That is all, And then I'm going to run another function called test, and what this does, what happened there? All right. What this does, I'm going to say print, so ul, all right. And then I'm going to say x is going to be func, right? And I'm going to say y is going to be 15, okay? And then I'm going to do something called result, all right? It equals to x plus y. And then I'm going to return the result. I was going to say return the result, but yeah, that's not how we do things. Yeah, okay. So let me just explain what is going to happen right now. All right, so now I have, okay, I'm going to say test result, or let's call A is equals to test, right? And then, I don't want it to give us the answer. I think it just did if you saw it there, but let us, let me explain what is going to happen, right? So I'm invoking this function test, right? And then what happens is when I invoke it, right? Well, it's not necessarily going to print it out now, is it? Now, when I run it. Actually, it might. It probably will. It would, yes. When I run it. So it's going to print this out, okay? And then I'm going to get here to line 8. And then what it's going to do is going to exit this function test and go into this function, right? It's going to say val, right? Then it's going to return val and then as 25, and then store it to x, and then it's going to continue, right? So it left our function for a bit, went to this function. Okay, so this is what's going to happen. I want to get the val as 25, and then I am going to store you as to this variable called x. And then from there, we do this operation, right? And then 15 plus 25 should be 40. If we run that, we say Python recursion.py, right? Okay, well, we didn't print A, so that's why it's not showing us the answer. So we can just do that again, and yes, we get our ul add 40. All right, it's 3 a.m. So let's learn some. Let's get to it. So this is just something I just wanted to show you about function of control. And if I was to, let's see, if we were to do something, let's do this, and then let's do plus that, right? So what's going to happen now is, right? So when I get here, I'm going to exit this function, go there, fetch my value of 25, and then this is going to become 25. Then I'm now in this function. I'm now going to do this operation, and that's going to be 50. If I'm not, my mathematics is still awake. And then I'm going to say 50, right? Plus 15 plus 20. Then I'm going to exit the function. Then I'm going to fetch that, and it's 25. So that's going to be 50, 65, 90, right? And then we're going to run it again. And there we go. All right, so I just wanted to show you this. Then we can move on to the recursion. We're going to draw some recursion trees, tracing trees, and see you there right now. Coolio. Okay, guys. All right, so I'm going to start with a quick function, right? And I am going to write define rec, right? And it's going to take us, let's call it n, right? And then I'm going to say if n is equals to, actually, you know what? If n, what I'm going to say is